Hello, welcome. So in the previous episode, we've been working on this circuit. It may look a little bit different, and that is because I have figured out how to get the FPGA working. So what you're seeing on screen right now is the actual HDMI output of the FPGA, actual hardware, and it's being captured by a super cheap HDMI to USB capture device. I think it was $15. There's like a dozen different sellers on Amazon for this device, and actually it works pretty well. So I was able to convert the circuit here into something that'll run on the FPGA with minimal modifications. Mostly I removed the simulated VGA adapter up here and I just put it out to output pins. And then I discovered that there's an extra signal that needs to be sent to the HDMI adapter that I'm using. So I generate that signal down here. It's just, for whatever reason, it needs to know where the picture is in the signal. So this just tells you that you've got a valid picture or not. So that's pretty much the only changes that I needed to make. And just to prove that it is actually working, let's change this to 0 instead. And then let's go through the process of actually compiling this to the FPGA. So we export to Verilog, and I've already prepared some other files in here. Yes, I want to overwrite. And then in the terminal, what we need to do is just go make. And I'm going to turn on the capture device so you can see what happens. So it's just going through and making. Now it's flashing the FPGA. And now you can see that what it's displaying is different. It's now starting at 0. So yeah, that is the process of building something for Verilog and actually running it on the FPGA, which is pretty nice. So I can show you around very, very briefly because this is not the point of this episode. But so I just have the output from digital, and it provides a module down here. If I can find it. Here we go. VGA FP, which is the name of the file that it saves. And it has these outputs and a clock input. So then what you can do is just wire up a simple top-level VHDL that takes in the actual pins on the device. And in this case, there's a red, green, and blue LED as well, and a clock input. And I have some logic to invert the red, green, and blue since they're active negative or active low. Some wires for wiring everything up. This is the magic sauce for getting the exact right frequency for the picture signal. For some reason, I misremembered and I thought it was 21 megahertz, but it's actually 25 megahertz. So that had me stumped for like an hour trying a bunch of different things till I looked at the spec again just to verify my numbers and, oh, it's 25 megahertz. Okay. So you might want to double check that if you're doing this. And then just wire up the module that digital produces and then wire up the pins. So, and here I've just got a bit of debugging code to try and figure out, is my clock actually working? And yes, it is. So I'm flashing the red LED just to see if it's actually doing anything. And it is. So this is pretty exciting. Let's keep working on this. So I'm just going to revert some of the changes I made to make this work with the Verilog output. And we'll just continue where we did in the last episode. And we'll figure out how to make these changes more official, I guess you could say. There we go. I believe this is reset. It goes up here. Just put it down there. Yep, there we go. We've got our VGA output. So what do we need to do? Let's leave the hack in here for now, or the test pattern rather. And let's actually put in the picture valid signal. Oh, is it already here? It is. Oh, so I didn't even need to do that. Okay, cool. So we've got the picture valid signal already. I don't know why I didn't realize that. And I guess we just need to put the picture valid signal out to a pin. And that should solve that. Output. Call this, I think on the device they call it DE, and I'm guessing that stands for display enable. I'm not really sure. I'm just gonna put it out to the same name. And actually they call this pin here HS for horizontal sync and VS. I am gonna just rearrange the pins here. Okay. And this monitor doesn't need this pin, but we've got it available if we need it. Okay, so what we need is another embedded circuit. And one of the things I'd like to do is extract out, well, basically everything from this. So what would we call this? VGA, VGA Gen? VGA Display, maybe? I'm just going to call it VGA Display. And I'm going to pull pretty much everything from here, except for the monitor, but, well, and the character ROM, I think. Yeah. Main reason for not having the character ROM is I need to do some special Verilog in order to end up using the block RAM. And the block RAM will be faster. Currently what it's doing is it's actually compiling the entire ROM into LUTs. So that's not ideal. I don't know what the speed is compared to doing it in a block RAM, but I'm going to guess the block RAM is going to be faster. So I'm not sure how to get a ROM to work properly, exporting to Verilog and have it actually become block RAM. So there's that. Now, what was I doing? Oh yes, output pins. We need 4 bits of R, G, B, and then we need HS, VS, and DE. Then we need our CA, and that was 11 bits, I think. And then we need our CD input, which was 16 bits, I believe. And I think that's it. Let's just wire everything up here. That looks to work. And this is going to be the wrong color, but that's okay. Oh, saying I need a label on my clock before I can import it. Okay. I guess I can go in here and open. I forgot to name this. And while we're at it, change these. There we go. That looks better. Let's move this out of the way here. There we go. All right. So now it'll be much easier to convert this to Verilog. I won't do that on camera, but then I can just export just this circuit here, and I can wire up the character ROM and the HDMI adapter separately. So then we're going to be mostly working on this circuit. What do we need to do? Well, we have just a static pattern being displayed, and what we'd like to do is have a dynamic display. So what we'd like to do is take the character X and Y, and depending on that, we'd like to change the character, the foreground color, and the background color. So let's actually make an embedded circuit for that, and let's call it VGA text. Oh, it's already there. what do we call it? VGA String, I guess. So we've got a clock input in case we need it. We have the CX. Is it 16? No, I think I had 8 bits. And then the CY. And then we output a character, which is 7 bits. All right, foreground color, which is 12 bits. And a background color. And actually what we want to do is we want to be able to chain a bunch of these. So actually we'll want to do this. And then on the inputs, we'll have a set of inputs for the same signals. Okay. And what we want to do is set up some multiplexers. And I probably need a little bit more space here. Okay. And we're going to have a common signal that indicates whether or not we're going to override these. So what I'm thinking is a string of text that's displayed on the screen is only going to have a single foreground and background configurable color. So yeah, this is going to get confusing, but foreground C for config, I guess. And background config. So move these down, and I'm just going to leave them crammed together for now. So, and then our character is going to be configurable depending on the address. So we probably want it to be down below here. Really don't think we'll need a clock. So now what we need to do is detect the address. The fastest way to do that is to use a number of bits. So I'm thinking we hard code the length of the string to be a power of 2. That way we don't have to use a comparator to check the address to see if this string is being displayed. So we could either go with 2 characters, which isn't really enough to display much. We couldn't even display a number with that. Or we could go with 4 characters, which is a little bit better, and we can display hex numbers using that. Or we could go with 8 characters, which would allow us to display a number and a few letters. So I'm not sure what is best, but a hex number is 4 digits, and we can always use multiple of these to display longer text if we want. So I think a module that can display 4 characters is good. So we want to match the row or the y coordinate exactly, and we want to match the x coordinate partially. So we just want to match the last few bits of the x coordinate. So what we could do is just use the comparator and just do an equals using the comparator for now. I'm not sure how this will be converted into Verilog, and it might need to be optimized. So 8 bits and 7 bits. No, 6. So we compare the upper 6 bits and we use the lower 2 bits for everything else. So I can do this. And then what do? Well, we can have an input that says what the position is. So the configuration for that, and this is 6 bits. And then we have the configuration for Y, which is 8 bits. So if both of these match, then we want to display our text. All right. So there's the logic for that. Still thinking I want this down here though. Now, what do we display? Well, we've got 4 characters, so we can make 4 characters configurable here. We can use a multiplexer to select which character. I got 2 selector bits, and there's our 7 bits. So, well, this is 8 bits in, 4 bits, well, 2 bits, and 4 bit, or 6 bits, rather. Okay, and then we have an input for each of the 4 characters that we want. I believe that's it. So let's change our settings here. I'm actually gonna try and get away with 3 here. So we might need to rename some of the inputs and outputs here. What's the order here? I think the order is okay for now, but I think that's okay too. All right, let's see it in action. Oh boy, that's big. All right. A couple of things. I'm going to make this I, and I'm going to put some outputs on here for these. And the other thing that I want is an enable signal. And the enable signal will go on here, here. All right. Yeah, I'm going to leave it at the bottom there for now. Okay, I think this is good. Oh, and everything's all jammed together. Let's see if we can fix that. That's better. Gotta space them out. We want to enable. Not sure what the middle row would be, but let's say it's 10. Oops. This is decimal. And this one, 6 bits. And I forget how many columns we've got. So let's just go with 4 and we can adjust later. Foreground color. Let's try that. Now we pass in the C, Y, C, but what we want to do is just hard code the first few signals as 0 for these other ones. So it's 12 bits. So. Okay. Get that out of the way here. Okay. Now I think we're almost ready to try this out. Character, foreground, background. Yeah, that's good. Okay. It's the beginning of hello. It is nothing else. It is just an abbreviation for hello. So, not trying to be controversial in any way. Okay. All right. So the intention is to put it in line like this, essentially. And then we can chain multiple modules because we can just wire between these. So these act like a bus that we can have a bunch of modules on. And I'm going to do my hello world. But first I want to check that the first few characters work. And I'd like the buses to be straight. So I'm going to move the clock down. Looks good. Oh, but buses won't be straight. Oh, well, I guess. Suppose I could move these 2 up. Yeah, let's do that. Open. In theory, this should work. Oh, I think I know what's wrong. We have to run this, and then it'll work. That's exactly what the problem is. So my font is not centered, but wow. Okay, so what we should be able to do is just copy and paste this and insert more. Let's make a chain of them. Let's see if we can display that. Let's put this at 10 as I originally wanted to. And this will be at maybe 6, 7, 8. Right. Oh, that's a little further over than I thought. And yeah. So we probably want 3, maybe 3 and 7. There we go. The exclamation point is not super well formed, but it's working. So there is one more thing that would be really nice, and that is a numeric display of some sort. So we kind of want most of the inputs and outputs from the previous one. Specifically all of these and all of those. And we don't want any of the stuff in the middle. Okay, and then now we need to configure the inputs here. So what we probably want is another embedded circuit. And in here, we just take 4 bits input, and this will be our digit. And we just multiplexer 4, 7, and an output. And we just need a bunch of these. Well, this is more like digit to ASCII. Okay, seems to work. All right. Oops. Let's put it over here. Yeah. So we want the most significant bits to be first, so they'll be on the left. And then the least significant bits we want on the right, so we want them last. Actually, this one can go back. And then we have our numeric input. Seems to work. Order inputs. Let's do that. All right. So we need a number. This is going to be running really fast. So I think in simulation, we probably want at least 10 bits. Well, let's just make it a 24-bit number, and then let's just take the top 16 bits. 24 bits, so input is 24, output is 23, 8. That kind of makes sense. Oh, whoops. Oh, that's interesting. It's being corrupted. I think I know what's going on there, because the number is changing in the middle of the picture. That's very interesting, though. Okay, how do we fix that? Probably, well, this is just a solution. There's probably many solutions, but I'm just going to go with a register. No, I want an actual register. And what I'm going to do is take this picture signal here and route that down into the enable, but I'm going to invert the enable. So it will only update this register when the picture is off. That didn't fix it. I'm surprised. I'm very surprised, actually. That should fix it. Well, that's the fun of digital electronics when you're working at very high speeds like this. I have no idea what's corrupting that. This should prevent it from changing while the picture is on screen. I suppose what I could do is slow it down. That sort of fixes it. Okay, well, that sort of fixes it. So we now have the ability to display arbitrary text, and we can use that capability to display arbitrary numbers now. So awesome. Yeah. So I guess in the next episode, we'll use this to start building out a bit of a front panel for our CPU. So thank you very much for watching. I hope you have a great day. Bye.